Welcome back to day 6 of 12 integrals. Thank you very much for sticking around, by the way, guys. Anyways, today we're going to be evaluating another integral again. Nothing too fancy. The integral that we'll be evaluating today is natural log of sine of x, and we have a limit from 0 to pi over 2 radians. I'll give you a bit of time to think about this integral, and I'll give you a little bit of clue that you again will need to consider another similar integral to try to make your life a bit easier. Do you think you guys have an answer? Do you think you guys will have an answer soon? Okay, so let's see what the answer to this integral is. So as I said, we have to consider another similar integral. And so the integral that we're going to be considering is the natural log of cosine of x to the same limit. So this is what we're going to do first. Let's try to plot the graph of natural log of sine of x and natural log of cosine of x. This is what it would look like. As you can see, that between 0 and pi over 2, the graph is pretty much identical, just mirrored image of each other, meaning that the area under this bit and this bit will actually be the same, which means that the integral that we have, the two integrals that I've mentioned, is actually going to be the same as each other. Now, how is that even making life easier? Well, let's take a look at how we can solve this integral now that we have this information.
Okay, so let's try to evaluate this integral, which I'll let this integral equal to I. And from what we already established earlier, just now, we know that this integral is exactly the same as the integral of natural log of cosine of x dx with the same limits, and that's just by looking at the graph, right? So now what will happen if I add these two integrals together? So when we add these two integrals together, we're just adding I with I. So 2i equal to the integral of natural log of sine of x, and I'm just gonna add, and because we'll be adding two integrals together, I can just combine the functions inside, which I'll just do, plus natural log of cosine of x, and all of this with respect to x. Now let's see if I can somehow change this the function that's inside. So I'll move over to this side of the page, and we'll try to see what we could do with that function inside. Yeah, so first, all we can do is we have two natural logs which are adding each other, and there is this particular log rule which says that when you have two logs adding each other, it is the same as just multiplying whatever's inside, and that's exactly what we'll be using here. So this equals to natural log of sine of x multiplied by cosine of x. This is, and in order to move from this step to this step, we have to use this rule. Now, how can we simplify sine x multiplied by cosine x? Well, there's another trig identity. I know there's a lot of things you need to know to do this question. I'm sorry about that. But there's this trig identity which says that sine of 2x equals to 2 times sine of x times cosine of x. So I could just divide both sides by 2, and then you just get that bit. So this is equivalent to natural log of a half times sine of 2x, like that. And going from this step, we have to use this identity here. And finally, we have a half multiplied by sine of 2x. So I can use the reverse of this rule to split it back out into two natural logs. So we have a natural log of a half, which will just be a number, plus the natural log of sine of 2x, like that. And so then this bit inside the integral is the same as this. And so I will just write this out here. So I'm just going to also split the function. I hope you can follow my quick splitting up of functions and stuff. So this gets split into two different integrals, right? So now it will look like this. Now we have two integrals that we need to evaluate, which is this integral and this integral. So let's do it right over here. So first we'll do the first integral, which is rather easy actually, which is just this integral that we have to evaluate first. Again, as I said, this is just a number. This is just a constant. So basically this is just a constant times dx. And so basically this just gets turned into the following. You can take the constant out and be multiplied by x. That's like the derivative of integral of 1 with respect to x. And we evaluate that from 0 to pi over 2. So the answer you get is just going to be pi over 2 minus 0 times natural log of a half. So that would just be pi over 2 times natural log of a half. That's just a really standard integral, right? Now the second integral is the problem integral that we have to try to work out. So this is the integral that we need to work out. So what we're going to do is we're going to do a bit of substitution. So I'm going to let u equal to 2x, which means that du divided by dx will equal to 2. And so what this means is that dx equals to a half multiplied by du. You could just flip stuff around there. And so I could replace that dx with that. And so what this becomes is it becomes the integral of natural log of sine u times a half du. But we have to be careful with the limits here because we're no longer differentiating with respect to x, we're differentiating with respect to u. So these limits here was written for x. And so now we have to change it to be whatever it is for u. So 0 is x, right? X equals 0. So in order to change it to u, you have to multiply it by 2 because that's the condition that we placed there. So 0 multiplied by 2 is just still 0. So that's the limit from u equals 0. And we can do the same for pi over 2, and then we get u equal to pi. And now we have to evaluate this integral here. But this integral here is exactly what we had earlier, right here. Except that rather than having the limit from 0 to pi over 2, we have it from 0 to pi. But if you look at the graph for natural log of sine of u, you'll find that the graph going from 0 to pi over 2 and pi over 2 all the way to pi is symmetrical. And so this here would just basically be double of whatever the integral was all the way up here. So ultimately, this bit here just equals to 2i because the area under the graph for natural log of sine u from 0 to pi would just be double of what it is from 0 to pi over 2. I actually have almost forgot this 1/2 here. So this 1/2 here is basically just a constant, right? So I could take that out and just rewrite this as 1/2 to be at the front there. So basically this is just the integral up there that I mentioned. I've probably confused a couple of people, I'm sorry about that. And this half could just divide by 2, cancels out, and then you just get I for this integral here. And so now we can work out the rest of this equation again. So basically what we have from earlier is we have these two results, and I could just replace it in there. So this bit would equal to, this integral here is this one, which equals to this. So this would just be pi over 2 times natural log of a half plus this integral here is just this result here, which equals to I. So this would be plus I. And remember that this equals to 2I. And so you could rearrange everything, and all you get is just I equals to pi over 2 times natural log of a half, which is the answer that we are looking for the integral up there. So this is the integral that we worked out, and this is the answer. I should probably have also squared the dx bit there. There you go.